This is a podcast on net ionic equations and how to write them. Net ionic equations are written to show only those species which are actually involved in producing the products of a reaction. Some of the more common reactions are precipitation, neutralization, and replacement reactions. Let's look at an example. The precipitation of silver chloride, which is produced by mixing solutions, say, of silver nitrate and sodium chloride, would be a good one. The first step is to write out what we call the balanced molecular equation. That is all the species in non-ionic form. And notice that the AgCl has the S after it for solid because it's the precipitate. The next step then is to write an ionic equation showing the strong electrolytes completely dissociated into their respective cations and anions. And I've left the AQ off for these ones. Silver ions, nitrate ions, sodium ions, chloride ions to make silver chloride, sodium ions, and nitrate ions. The final step is to cancel out the spectator ions that are on both sides of the equation and write out your net ionic equation. That is, only those ions that have ceased to be ions. They have changed. Another example would be the neutralization of acetic acid with potassium hydroxide. Here again is the so-called molecular equation. This is the acid plus the base makes the salt and the water. Now we want to write out the equation showing only the strong electrolytes as being dissociated. And so because acetic acid is a weak acid, here we have it still written as CH3COOH. Potassium hydroxide is a strong electrolyte, and you can see the ions. The next step is the same. You cancel out the spectator ions, in this case just the K+, and here our net ionic equation is CH3COH plus OH minus makes the water and the acetate ion. Interestingly enough, if that was a strong acid like HCl, we would have H plus OH minus makes water as our net ionic equation, and indeed that is the net ionic equation for all strong acid, strong base reactions. A third example would be the reaction, say, of silver nitrate with copper metal in a classic replacement reaction. The silver nitrate reacts with the copper to produce copper nitrate and silver. Write out your ionic equation, cancel the spectator ions, and our net ionic equation is 2Ag plus the copper, making the two silvers and the copper 2+.